is Martha, and I'm doing chapter 11.1 with exponential and logarithmic functions. The learning target for today is to evaluate and simplify expressions consisting of rational exponents. Now for the variable in the definition section of this part is going to be in parentheses with an exponent, and then there's going to be an exponent on the outside of it as well. And what this means here is these exponents are multiplied with each other. So now when we come and do the example with numbers, we'll use a 9. We'll put a 3 as the exponent on the inside, and then a 2 is the exponent on the outside. And when we come out here, this would be now your exponents are 3 and 2, you would multiply those together, so this comes out to be number 6. Now with this exponent here, each of these variables right here are going to have the m as an exponent when we do them separately, so it's going to have a to the power of m over b to the power of m. And then when we go in and do an example of it, we'll use 3/4 to the power of 5. And when we rewrite this, this is going to be 3 to the power of 5, and then 4 to the power of 5. And if you want to go in and continue this, you can do 3 to the power of 5 with the actual math, which comes out to be 243, over 4 to the power of 5, which is 1,024. So that would simplify for the power of quotient. Now we go in and do the power of product, and we have the variables multiplied together, and then out here, the exponent is going to be on the outside again. And what this would be is kind of similar to this. The a gets the m, and so does the b. They both get m's, except for in this one, they're going to be multiplied by each other. So now when we go in and do an example of this, we'll be using 5, and then the variable of x to the power of 3. When we go in and actually put this in there, it's going to be 5 times x to the power of 3. And then if we want to simplify this further, it would be 125x to the power of 3. And this is because when this is to the power of 3, this would be 125. And then this alone, you can't simplify it anymore, so it would just stay as x to the power of 3. Now for the quotient, we have am over b to the power of m. This would equal a, and then these exponents would actually subtract. So this is going to be the opposite of product. Now when we come and actually use this with numbers, we'll use 15 to the power of 6 over 15 to the power of 2. When we rewrite this, this is going to be 15 to the power of 6 minus 2. And then in total, this would be 15 to the power of 4. And you could simplify it further as an example of power of a power, except for in this example, the exponent is going to be a fraction rather than just a whole number. So we're going to do 125 to the power of 1/3. Now when we rewrite this using the powers of properties, or the properties of exponents, using power of power, we find that this would simplify down to 5, because that is going to be a third. Well, this is the root of 125, would be 5. And then it will be 5 to the 3rd, 1/3 still. And then when we go in and simplify this some more, it would be 5, 3 over 3, because we're multiplying these together, and that would make that a whole number. And then in total, this would just be 5, because 5 over 1, which is what this would equal to, ends up being just a whole number. For my example number 2, I'm going to be doing product and quotients. And for that, this is going to be our example that we're using. When we go in and simplify this using the methods that I've shown you guys, we'll add these together, the 4 and the 8. This is an example of the product, the product for the properties. And then this will still be, well, technically we could just do this in the parentheses and subtract this by 5, because when you have a division, when you have a division problem with these, that would mean that the 5 is being subtracted from this. Now when we go in and actually simplify this, this would be 2 to the power of 7. And when we go further, this would be 128. Now you can plug that into